So we are going to more on polynomials. Because again, eventually we want to solve equations. That's the whole purpose of algebra. And thus far, we only know how to solve linear equations, right? As was shown on the exam to some degree of accuracy. But yes, we like linear equations, right? You know, if for whatever reason I decide to give you your final right now, no? Hey, I can do whatever I want. It's true. Would you like to take your final right now? No. But, okay, so no then, right? Okay. But, let's say the whole final would consist of problems of, I don't know, this type. Solve for x. Or, would you like that? If the entire final had like 100 questions that were all like that. Yeah, right? You would all get an A. Wouldn't it? Because we like that. This is easy to us, right? How do we solve the first equation? Add 4. So 2x equals 4, then divide by 2. X equals 2. And the other one? Add 7. So 3x equals 10, right? Divide by 3. X equals 10 thirds, or 3 and 1/3, right? That makes us happy, doesn't it? I know. And at the same time, let me try something here. If I were trying to open I already forgot what I said. Do you see that second line? 2x cubed minus 3x squared minus 11x plus 6? Somebody write that down and then read it back to me. -2, -3, -11, 6. So that really neat. So 2x cubed minus 3x squared minus 11x plus 6 equals 0. Because if I ask you solve this equation, we would be a whole lot of luck. I mean, I don't even know where to begin. The way it's written, this is a very hard equation to solve. The linear equations, like those ones, are really easy to solve. This equation is really hard to solve. And the way it's written, I mean, back in the day, you could actually earn living by solving these types of equations competitively. Believe it or not. I'm talking about maybe 1600s. You can actually earn living by going to, tournaments. No, I wasn't, no. Because back then it was just like ridiculously high-tech type of operations. Okay? And it's a third-degree equation. It's a third-degree polynomial. It's a cubic equation. I mean, there's stories written about those tournaments, how the guys were coming up with clever ways of solving them and not sharing and stealing each other's secrets and getting stabbed in the eye. There's a guy who got stabbed in the eye, and he wrote a math book, and we actually study his mathematical findings, and we use his techniques, and he was kind of a badass of mathematics. He was a gambler. He understood probability before anyone else knew that there is such a thing, so he was making a very clever bets. Yes? Yes. Well, but anyways, there is a way to solve them generally, but what if I told you that solving this equation was equivalent to solving these three equations? Oh, I don't remember. What would you rather do? Solve the first equation or the next three equations? Next three equations, right? It's not even a contest, right? If I gave you options, solve one equation, that's the first one, or three little ones, what's the solution to this one? X equals -3. What's the solution to that one? 1/2, right? We add 1 to both sides, so 2x equals 1. So x equals 1/2. What about the last one? X equals 2. Well, my claim that by solving these three equations, I just solved the big one. All I'm saying is, I believe that those three solutions would actually solve the original big nasty equation. Now, how can I make sure? Plug it in. Now, I was, not exactly 100% sure. I was just trying to remember things, and I'm sure I'm remembering them wrong. Yeah, I am remembering them wrong. I did remember these things wrong. Sorry. This should have been -3. This should have been +2. So that makes this +3. That makes that -2, right? Sorry. But anyway, so how do you make sure? So let's say x equals 3. How do I know where that works? If I take x equals 3 and I plug it into my original equation, will that equal to 0? That's really what I'm testing. So this is 2 times 3 cubed is 27, minus 3 times 3 squared, that's another 27, minus, maybe it won't work, I don't know, minus 33, no, that looks to 2, plus 6. Well, that equals 0. Does that equal 0? 2 times 27 minus 27 is just 27. And -33 plus 6 is -27. So yes, that does equal 0. So that checks out. Right? So 3 is one of the solutions. Yeah, isn't that would be... Oh, I know, that's a very good question. Like, how do you know that? Because, that can't be just random, right? There is a reason why those were the three equations that I chose. No, there is some other things involved, but I don't know. Well, let's check the rest of them just for the sake of argument, that they all work. You don't need to write this down, but if I plug 1/2 into my equation, 1/2 cubed, minus 3 times 1/2 squared, minus 11 times 1/2, plus 6, will that equal 0? And I'm going to do this computation really fast. Don't write this down. The first one is just 3 over 8, minus 3 over 4, minus 11 over 2, plus 6. The common denominator is what here? 8. So that means we have 3 minus 6. I have to multiply this by 2. I have to multiply this by 4. So minus 44. And I have to multiply this by 8 plus 48. Right? That doesn't look right. Well, that doesn't work. Did I write this wrong again? What is 6 times 8? That's 48, right? 48. Why is it not working? Oh, because I wrote the problem wrong. This is 2. This is 2 here. Sorry. See, I shouldn't be rushing through this. So this is 2. This is 2. This is 2. Now that works. That's 0 over 8. So that's 0. Sorry. So that worked. And negative 2, if I plug a negative 2 in there, again, so this is 2 times negative 2 cubed minus 3 times negative 2 squared minus 11 times negative 2 plus 6. Is that my equation? So this is, what is negative 2 cubed? What is 2 cubed? What? 8? So negative 8 times 2 is negative 16. Negative 2 squared is what? 4 times negative 3 is negative 12. This is positive 22, positive 6. So that's negative 28, positive 28 equals 0, right? So yeah, so we found those 3. I mean, we didn't find them. We just kind of bumped into this. But we realized that we much rather be solving this 3 little equation than just being stuck with that, right? That's the whole point. Now, how do we go from that big ugly equation to the little 3 equation? Is that we need to discover the technique that we call factoring. And this will be the big finish in this class. At the end of this class, we'll focus on factoring. Which means, and here's an example of what it means, that original equation, 2x cubed minus 3x squared minus 11x plus 6 actually equals a product of x minus 3, 2x minus 1, and x plus 2. The product of those 3 parentheses on the right actually equals that big cubic on the left. So factoring is one of the most important algebraic techniques. It allows us to make our big equations into smaller equations. Okay? Now, to actually factor that, you'll have to wait till, about a year or even more till we get to this form of factoring. This is really complex. Okay? We actually do that in college algebra if you're lucky. If you have I don't know, well, lucky. Well, I don't even think he'll teach that. I will. I'll teach the crap out of that. Because that's actually, it's very strange, but it's in a section in the book that contains a theorem that's called the fundamental theorem of algebra. That sounds very important. So that's why I like to teach that, the fundamental theorem of algebra. Yeah, but you have to wait till about week 8 or so of college algebra to get to that. So you're about a year away from this type of factoring. But we'll get to some basic factoring in this class, and you'll do more factoring in 099. And technically, you know all the factoring before you get to college algebra, and then you'll learn some of those fancier techniques. But for now, we just want to see, well, how is that true? Like, how do I actually show that that's true? How is this product actually equals that? Can I multiply those 3 parentheses? So first, we need to learn how to multiply algebraic expressions before we actually learn how to factor. Okay? So before we learn factoring, we need to learn how to multiply. So first, learn how to multiply. So we already played with, and we're pretty okay with, the distributive property. and you've done the distributive property since almost day one on this class. You used it on the test, but basically every time I have a item outside the parentheses, I can distribute that item through the parentheses by multiplying each item in the parentheses. So that equals AC plus AD, right? And we have done that. So a few examples. If I have 5 with 3 minus 2x on the inside, we should be very comfortable with that, right? We'll just distribute 5 times 3, that's 15, minus 5 times negative 2x is negative 10x, right? Are we okay with that? Let's try this. Negative 2x times 4x squared minus 5. So now I have to keep my rules of exponents at check. Because when I do the first product, I have to multiply my coefficients, so negative 2 and positive 4, multiplying them. What do I get? Negative 8. But when I multiply the variable, so x times x squared will give me what? X cubed, because I'm using my rules of exponents. Because I know to add exponents in this case. Are you okay with that? Because really what's happening, if I write this intermediate step, which we don't have to do, it is negative 2x times 4x squared. And then the next product is negative 2x times negative 5. Really, this is what's happening. And then I need to do my whole standard form thing to actually combine the exponents. And we finished, we did that right before the test. So that gives me negative 8x cubed plus 10x. Is that okay? Of course, we don't need to do that intermediate step. You should be able to do this in your head by adding exponents and so forth. Is that okay? How about 6x to the 4th times 3x squared minus 10x plus 1? The fact that we have 3 terms in the parentheses, is that going to slow us down? Not really. We're just going to continue with the same process. 6x to the 4th times 3x squared. So what will that give me? Right, so you multiply the coefficients, so that's 18, and then you add exponents, that's x to the power 6. Now, how about the next product? Right, we add exponents there, so it's negative 60x to the 5th, right? And finally, times 1, right, positive 6x to the 4th. How's that? Right, because they all have different exponents, so that's all I can do. I cannot go any further. Is that what you were saying? Right, because those are not like terms. They have different variable components. So I cannot add x to the 5th with x to the 4th. They have to have same powers in order for me to add them. I can multiply them, as before. You can multiply different exponents, but you cannot add different exponents. Is that what you were saying?
Yes.
All right. You're welcome. Now, how about this problem? And don't laugh at this, because this is very important that we understand what is happening. Can you do this? What we'll do, well, yeah, we'll see. How do we do that product? So we have something sitting outside the parentheses. I don't really know what that something is. Could be anything. Yeah, so happen to be the smiley. Smiley face could represent anything I like right now. It's just some other mathematical entity. Yeah, so but I should still be able to do my distribution. What? Yeah, well, we'll see how. If I replace my smiley face with something else, so it feels that, feels good, right? And it, good. So that's right. That's what will happen. Now, if I put the smiley face on the other end, is that going to cause any trouble? Does it matter from which side of the parentheses we distribute? So it's the same thing, right? It will still give me, well, technically A smiley face and B smiley face, but sometimes you do, right? If I write this, 3x minus 2 with the x cubed on the outside, you should still not be threatened by that and just write 3x to the fourth minus 2x cubed. Okay? A distributive property still applies from whichever end you do the distribution. Okay? So is that all right? Okay, well that takes me to this product. Well, what if I have a product of two parentheses like that? And some of you already know how to multiply parentheses that have binomials, right? You've done that. But if I actually go through the motions of discovering this new rule to multiply two parentheses like that, and all I have is the distributive property, that's all I have, right? And I played with the smiley face a little bit. I should be able to still do that. Don't write this down. But all I see right now is that I have a parenthesis with something on the outside, right? I have a parenthesis multiplied by something, just like we had before, parenthesis multiplied by the smiley face, right? And that smiley face went in and multiplied each term in the parenthesis. So that means I can take this whole parenthesis multiplied by C and take this whole parenthesis multiplied by D. Don't write this down, because I don't want you to. Because if you look back, it'll confuse you. Okay? But do you agree that feels like we're getting A plus B times C plus A plus B times D? Is that right? That's kind of what happens. You took that entire parenthesis and you dragged it through the second one. You distributed it through the second parenthesis, right? Well, if I distribute those, I'll get AC plus BC plus AD plus BD, right? So really, this is the rule. What just happened, and you should just write this down, that each element in the first parenthesis multiplied with each element in the second parenthesis, right? I do have a product AC, right? So AC. Plus, I do have a product AD, right? I do have AD in my previous computation. I do have a product BC, and I do have a product BD. So this is how we really want to think about the product of two parentheses. Each element in the first parenthesis multiplies with each element in the second parenthesis. You've known that before, right? What do you call that? Foiling, yeah. Well, everything is math that we're doing right now. But yes, it's called a FOIL, because F stands for the product of the first, right? So F first. And then O stands for the outer, right? If that helps, I don't know how that's supposed to help, but and I stands for BC, so the inner, and L, the product of the last terms. So yes, it's FOIL. Of course you do. You've all done that. And the FOIL is not limited to a binomial times a binomial. I can do a trinomial times a trinomial. It's just the idea stays the same, that each element in the first parenthesis has to multiply each element in the second parenthesis. So if you just keep that in mind, you're going to be all right. So for example, if I want to multiply 3x minus 1 by x plus 2, I will have to use that FOIL technique. I'll have to multiply the first terms. 3x times x is 3x squared. I have to multiply the outer terms, that's 6x. I have to multiply the inner terms, that's negative x, and multiply the last terms, that's negative 2. What? You've mentioned it every time we started something new. And then, yeah. I specifically recall you saying, oh, yeah, I remember liking that. And then it all goes to, yeah. Because I feel challenged, and then I have to, combine like terms. If you combine like terms, what do we get? Right. So, good. So this is what you get when you multiply these two parentheses. Does that make sense? Little FOIL. How about, well, now we're just going to do a bunch of examples, and then you do a bunch of examples on your worksheet with some old problems. But how about 2x to the fourth minus 3y, I don't know why, but how about y in there, and x minus 2, like that. So again, multiply the first, 2x to the fourth times x gives me what? 2x to the fifth, and then 2x to the fourth times negative 2 is negative 4x to the fourth, and then negative 3y times x is just that, negative 3xy. There's nothing I can do, so negative 3xy. And finally, negative 3y times negative 2 is positive 6y. Right? Can I combine any? Right. So they're all not like terms, they're all different. So that's it. That's my answer. So that's how you FOIL. Is that good? How about this problem? 2x minus 3 squared. So what does that mean if you square something? Yeah, multiplying by itself. So really this means 2x minus 3 times 2x minus 3. That's what squaring means, multiplying by itself. So then we can FOIL that. 2x times 2x is 4x squared. 2x times negative 3 is negative 6x. Negative 3 times 2x is another negative 6x. And negative 3 times negative 3, positive 9. Right? And if you combine like terms, we'll get 4x squared minus 12x plus 9. Right? And this will be the correct answer. Notice how it's not just simply squaring 2x and squaring 3. There is some other stuff in the middle that we would lose otherwise. Is that okay? But again, the concept behind FOILing is that each term in the first parenthesis multiplies with each term in the second parenthesis, regardless of the amount of terms in each parenthesis. Because if I decide to do this, x plus 2 times 3x squared minus 4x plus 1, so if I multiply a binomial by a trinomial, I should still be able to do that by dragging each term in the first parenthesis with each term in the second parenthesis. You just do 2 at a time. You do 2 into 1, 2 into 1. Well, it's all right. I'll see. That's exactly what I'm talking about, because I'll be doing that. and that's when you'll change your mind. But is that all right? Same concept. So x times 3x squared is 3x cubed, right? Then x times negative 4x is negative 4x squared. Then x times 1 is just x, so plus x. And then 2 times 3x squared is 6x squared. 2 times negative 4x is negative 8x. And finally, 2 times 1 is 2. So we ended up with 6 terms, because you multiply 2 by 3, so that's 6. Combine like terms, you might end up with a fewer terms in the end. So 3x cubed. What else? Right, so you have a negative 4 plus 6, so that's 2x squared. Then you have x minus 8x. So negative 7x, and then plus 2. So that's that. Are you feeling all right about that? Okay. So, if I multiply, what was that? If I multiply x minus 3 by 2x minus 1 by x plus 2. So that's what you were talking about, multiplying a bunch of parentheses. So just do 2 at a time. Pick any 2 parentheses and multiply them first. Which ones would you want to start with? Doesn't matter, whichever you like. You can do first 2, you can do last 2, you can do first and the third. This is the only options, really. So it doesn't matter. Let's just do first 2. Does not feel natural. So if I do the first 2 parentheses, x times 2x, that's 2x squared. And then x times negative 1 is minus x. And then negative 3 times 2x is negative 6x. And then negative 3 times negative 1. Now keep in mind, I'll still keep them inside the parentheses because I have that x plus 2 still. Is that okay? Combine like terms, we'll get 2x squared minus 7x plus 3 times x plus 2. So we started with 3 parentheses, we FOILed 2 of them, we ended up with 2 parentheses. Well, I still have to continue with my FOIL, right? So I can do this. Again, each term multiplied by each term, so 2x squared times x is 2x cubed, right? 2x squared times 2 is 4x squared. Negative 7x times x is negative 7x squared. Negative 7x times 2 is negative 14x. Is that okay? And then finally multiply by 3. 3 times x is 3x, and 3 times 2 is 6. Combine like terms, what did we get? 2x cubed minus 3x squared minus 11x plus 6. Right? So this is how, if I go back to that example, this is why, well, it's not how you do it, but you can actually check whether this expression factors into the product of those 3 by doing the FOIL a few times. Till you get rid of all the parentheses, you should get the thing on the left. And we did, right? After we did that big FOIL, we ended up with the original problem. Now, how to factor, that's the whole different thing. This is the hard part. The FOILing is the easy part. Multiplying parenthesis by the parenthesis, if you just stick to the rule, each term in the first by the each term in the second, you're going to be okay. Is that all right? Okay. Let's try this one. X plus 2 cubed. What is your first urge with this problem that you really, really have to fight? What feels like should be the answer here? Nobody has that urge? Good. I'm not going to then say that. But all right, so what do you want to do then? Good. Write it out. X plus 2, X plus 2, and X plus 2. Very good. So that's what it means to cube something. So right, so let's do the FOIL of the first two. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. And 2 times 2 is 4. Is that okay? Combine like terms. X squared plus 4x plus 4 times x plus 2, and repeat the process. Actually, it's easier if you go from right to left in this case. If you go smaller parenthesis by the bigger parenthesis, you can still do that. So if I multiply everything by x, I'll get x cubed plus 4x squared plus 4x. So I just dragged x through that big parenthesis. By the way, it doesn't matter which way you do that. We should all arrive at the same answer. And when you multiply everything by 2, you'll get plus 2x squared plus 8x plus 8. So we'll get x cubed plus 6x squared plus 12x plus 8. Is that okay? Any questions on how we got that one? No questions? Sure. So again, we interpret the powers as they should be interpreted. Cubic means multiply by itself 3 times, and then just kind of start foiling. Are you ready for the tournament? We discussed the 1600s or whatever. I'm going to write something on the board, and you're going to try to do that. You want to try? What'd you get? I just wrote down the answer. Because at some point you should be multiplying -5 by -5 will give you positive 25. Yep. right? Because if you write it out, this is 3x minus 5, 3x minus 5, so we'll go 9x squared, right? Then we'll do it again, so that's negative 15x. Then we'll do it again, that's negative 15x. And then we'll do this again. So negative 5 times negative 5 is positive 25, so that's 9x squared minus 30x plus 25. Is that okay? How about this? Oh, this is going to be fun. I'll be nice. No, I won't be. I'm just writing down the answer. Well, I'll write down the answer. You're going to do, like, a lot of work, but then you'll match the answer.